condensing some log expressions here. So we want to condense these into a single logarithm expression. We have to have the same base, which we're fine here. We've got log base 8, so nothing weird going on there. Before you can put logarithms together, you must deal with the power property first. If there are any coefficients in front, you need to move those first. Unless you're looking at a scenario where it is the exact same log expression. So if we had log base 8 of 5 and log base 8 of 5, then we could add those together and get 35 log base 8 of 5. But because of the number inside the logarithm being different here, we must apply our power property first. So coefficients become exponents. So I'm just going to express that with an arrow here. Now, we do not want to evaluate 5 to the 30th. It is a massively huge number. So we're just going to leave that. 2 to the 5th, not really that bad, but we're just going to leave it for the time being, because that's not our focus. Our focus is we're trying to condense this into a single log expression. So now we've moved those coefficients. We have the same base on our logs, and it is the sum of logs. So the sum of logs becomes the log of a product, the single log of a product. If you want to put parentheses around that, you can. You technically don't have to. And that's as far as we're going to take this. We've condensed it down to a single log. That's all we're going to do, because 5 to the 30th, huge. That would require scientific notation, so we're just going to leave it. 2 to the 5th. If it's just killing you, you can write that as 32, but I would just leave it. Okay, so you can do it with just numbers. We can also do it with variable expressions. So B, we have 1/2 log of x plus 3 log of x plus 1. So dealing with a common log here, there's no base, so it's understood to be 10. Again, if that was the exact same log expression, if both of these were just x, or if both of them were x plus 1, then we could just add them together. But they are not the exact same log, so our coefficient to power gets applied first. So that's x to the 1/2 plus log of x plus 1 cubed. Is there another way that we can express the 1/2 power? Anybody remember what a 1/2 exponent represents? Okay, we'll deal with that in a second. We're adding these two logs, so it becomes a single log of the product. The 1/2 power is the same as the square root. Y'all seen that before? I think that's a math 2 thing, maybe. The 1/2 power is the same as the square root, and that's usually how you will see that expressed as a multiple choice answer choice or on the answer key. That 1/2 power they're going to express as a square root. And again, you really don't need parentheses, but if you want to put parentheses around that entire expression just to make it clear to you that all of that is inside the logarithm, then that's fine. You can put parentheses there. They're not going to show up on the answer key, I don't think. But all of that is inside that single log. Okay, let's do just a couple more here to make sure that we've covered all of our bases. Let's look at a natural log, and this one is a difference. So we haven't done one of those yet. 2 natural log of x plus 2 minus the natural log of x. Same log, different expressions inside. So we can't just add them or subtract them in this case. We must move that coefficient to become an exponent first. And then this time it's the difference of two logs. So that becomes the log of the quotient. Whichever one comes first is what goes on top. And then whatever follows is the denominator. Sometimes you may run into a scenario where you can simplify that. At this point, this will not. X plus 2 squared. There's nothing that will cancel when it's just over x. So it's worth looking at to see if anything was simplified, but in most cases, that's usually as far as it'll go. Okay, and one more here. This one's a little different. It's log base 2, and the entire expression is over 3. So we're going to handle this one just a little bit differently. I'll give you a second to write it down before we start simplifying. So because of the way that this one's set up, since the entire expression is over 3, we can start with simplifying that numerator. We can, since it's the sum of 2 log base 2's, then we can go ahead and express that as the product in a single log, log base 2 of x times x plus 1. And that is, of course, still over 3. We just simplified the numerator there. Now, dividing by 3 is the same as multiplying by 1/3. I'm going to go ahead and write it that way because we don't have a rule if we're dividing by a constant, but just remember that dividing is the same as multiplying by a fraction. Now we can apply that power rule. Now here is a case where we need parentheses because we have that x and the times x plus 1. We do need to put parentheses around that entire expression because if we don't, then technically that 1/3 is only being applied to the x plus 1. But it's really to the entire thing. Now, if the 1/2 power is the square root, what do you think the 1/3 power is? Cube root. So that is how you will likely see this answer expressed, is the cube root of x times x plus 1. An entire expression is under the cube root.